Now, we have studied about this, right? That reflection occurs when a light beam strikes any polished, smooth, or bright object and bounces back to our eyes. This phenomenon gives us a basis on which to view the environment. Light propagates in a straight line before, after, and during reflection. Okay, we studied that how light travels in a straight line. Okay, then we studied about the beams of light. Okay, light beams are of three types: parallel beams, convergent beams, and divergent beams. Now, this is the diagram of reflection of light, okay, where all of the components are marked. What are the components? We have incident ray, reflected ray, normal, angle of incident, angle of reflection, and medium. Okay. Okay, let's check them out. Normal is a perpendicular drawn to the reflecting surface at point M. Okay, can you see that in the center a dotted line is there? Okay, that is known as your normal. At point M, known as the point of incidence, is called normal to the reflecting surface. Mirror is the reflecting surface below. Incident ray, a ray of light that falls on the reflecting surface from a light source or an object, is known as the incident ray. Okay, this incident ray, can you see falling? Okay, this one is the incident ray. Okay, then reflected ray, a ray of light that arises from the reflecting surface after reflection from it is called a reflected ray. Okay, it's arising from the surface.
Okay.
Yeah, so it is yes, reflecting after, like reflecting from the surface after the incident ray is falling is reflected ray. Angle of incidence, the angle between the incident ray and normal to the point of incidence on the reflecting surface is known as the incident angle. Okay, or bugle of incidence. It is denoted by I. Okay,
Okay, ma'am.
now between the incident ray and normal, the angle formed is angle of incidence. Between the reflected ray and normal, the angle formed is known as the angle of reflection. The angle between reflected ray and normal to the point of incidence on the reflecting surface is known as the angle of reflection, denoted by angle R. Principal axis, defined as a line that divides the two mediums or the reflecting surface, is called the principal axis.
Okay, ma'am.
Now, any doubt in any of the components of the diagram of reflection of light?
Ma'am. No, ma'am.
Okay. Can you draw this right now?
Yes, ma'am.
Yes. Please draw this.
I'm done.
Done. Okay. Now please write down these important terminology, their meanings. Hello, Abraham. Good morning. Abraham, you can also write these down.
Yes, ma'am. Ma'am, I sent you my test, ma'am.
Okay, I received it.
Yeah.
Ma'am, can you go up for 1 second? I've just got to say, I think I made a mistake in the diagram.
Yeah. Abraham, you also have to draw this diagram. Reflection of light. Okay. It mentions all the components, mentions the incident ray, the normal, reflected ray, angle of incidence, angle of reflection, and medium. You're saying something? You're muted. You are muted, Abraham, if you're trying to say something.
Ma'am, the line of normal, I think it's always there 90 degrees. And whenever there's an incident ray, it is always equal to the reflected ray.
Yes, Abraham, normal is always at 90 degrees. Okay, that is correct. And angle of incident, the incident ray is equal to the reflected ray is also correct.
And ma'am, if we had what do you call that? A normal, maybe a sheet of glass, this would come enter in because glass is a slower medium. I think the ray would tilt towards the glass.
Mhm. Probably yes. This is reflection taking place in a mirror. Okay, done, Emma?
Yes, ma'am.
Okay. Abraham, you can write this down first, and then you can draw the diagram also. Okay?
Ma'am, can you just repeat?
Yes. Please write this down first, and then you can draw the diagram. Okay?
Ma'am,
Yes.
the angle of incidence, can't I just write, ma'am? The angle formed by the incident ray and the normal line.
Yes. Yes, Abraham. The angle formed by the incident ray and the normal line.
I missed writing incident ray. Can you go a little up?
Yes.
Ma'am, principal access is not there for us, right, ma'am?
Principal access is not there for you. Okay, you can write this down, but it is there in the creation of image. Okay.
Ma'am, I won't write it down, ma'am, because I don't understand what it is.
Okay. Mm-hmm. I'll explain you what it is.
Okay, ma'am.
I cannot see the incident ray still.
Okay. Here you go, Emma.
It is, um,
Ma'am, there's no definition for normal.
There
there
is
is.
a the first definition is of normal.
Now, this reflecting surface can be two things, right? Now, it can be a surface and it can be a plane mirror also, right?
Yes, Abraham, yes.
Because the surface will reflect the color of light, but the plane mirror will reflect, I think, the whole light. I'm not sure.
Mm-hmm. Yes. Okay.
Ma'am,
Yes.
I'm for a plane mirror, ma'am, we'll draw a line, and under that line, we'll draw slanting lines, right? Small ones.
Mm-hmm. Yes, but I'll teach you mirrors, okay, or lens separately. Okay. I'll teach that to you separately. So that time we'll do it with diagrams. Okay. The formation of image also we will do for mirrors, and then we will do for lens, like with lens. Okay. How mirrors are formed, like mirrors, real and virtual, and lens. Okay. Principal access, I'll explain you. You can just write the definition right now, and then once you've written everything, I'll explain it to you on whiteboard. Am I written?
I'm just finishing principal axis.
Okay.
Ma'am, I understood what's principal axis.
Okay.
Ma'am, it's basically when light is getting refracted or it's entering another medium, there will
Mhm.
be a principal axis drawn to say that it's entering another medium, and then you write water, the name of the medium from where the light is coming, and then on the bottom.
Okay. I didn't get that fully, but I can show you a diagram and then I'll tell you. Okay. Okay. Written everything, Ibrahim?
Yes, ma'am. I was saying, I think principal axis is that line in when you're doing the refraction of light, that line that comes in the between that separates the medium of air or an example water or glass.
Okay. I don't think that's the principal axis, or I don't know if that's what you're talking about. Okay. Can you see this diagram? Can you see this diagram of concave mirror and convex mirror? There is a purple line, okay? There's a purple line that is passing through the middle part, okay? Through right in the middle of the both the mirrors, okay? This is the principal axis, and it helps us to find the focus point also, okay? To find focal point also, the principal axis, and it also sets the uniformity of the of our rays of incidence, okay, and the rays of reflection. Right. See, it is like an imaginary line, okay, and if you can see in the convex mirror, here is the focal point, okay. It helps us to locate the focal points because the principal axis passes right at the center, and also when the other light reflection, when other rays of incident will come, okay, it helps us see their uniformity. Okay, these are parallel beams. Then if you have convergent beams, okay, or if you have divergent beams.
So, ma'am, the what you call the principal axis, ma'am, is ma'am,
This one.
is this line.
Yes, it is this line which passes through the mirror's pole and center of curvature. Okay, see this point right here. Okay, where the mirror is curving and it's passing through the center. This is known as center of curvature. Okay, this is known as center of curvature, and it passes through the center. Okay, through the center of curvature, okay, the principal axis, and it helps us to locate the focal point. Okay, understood. This is actually your principal axis. Okay, we make it in the concave mirror convex mirror diagrams. Okay, that time we make it. Now, Ibrahim, have you drawn this diagram? This diagram? Have you made this diagram?
Just ma'am, 1 minute, I just can't see it.
You cannot see it?
Yes, ma'am, I know this diagram.
Okay. Okay. If you want, you can draw it. Okay. Like you have to draw it. In your book, it is mentioned, okay, all of these things, incident, reflected ray, but in not very detail, only the names were mentioned, but these are like actual meaning of them. Okay, if it is asked, what is an incident ray or what is a reflected ray? What is the angle of incidence and angle of reflection? So you are now able to define them, define each of them individually. Okay, what is the meaning of each one of these? Okay. The mirror is also referred to as the medium.
Ma'am,
Yes, Abraham.
ma'am, I drew the thing, ma'am. My angles are not accurate. Can I draw it again?
Your angles are not accurate. Um, you can draw it later on. Okay. You can draw it later on again. Okay. And I'll share this diagram also with you. Okay. Now, let's quickly see the laws of reflection right now. Laws of reflection. You must understand two necessary laws of reflection after learning what it means. These rules can be used to calculate how the incident ray will reflect on different materials such as plane mirror, water, metal surfaces, etc. Here are the laws of reflection as they apply to a plane mirror. Okay, this is a plane mirror PQ. Okay, PQ is a plane mirror, and the line that is passing, like the line is normal. The diagram is just tilted. Okay, and normal is there. Incident ray is hitting PQ, and the reflected ray is coming back. AO is incident ray, OB reflected ray. Okay. Then with between the incident ray and normal, I angle, that is angle of incidence, is being made. Between the normal and reflected ray, angle R, that is angle of reflection, is being made. Now, when in the point where your incident ray and where your incident ray is hitting and reflected ray is coming back, is known as O. That is the O point, and known as the point of incidence. Okay, known as the point of incidence. Now, with reference to this diagram, okay, the incident ray, reflected ray, and the normal all lie on the same plane. What does this mean? The incident ray, reflected ray, and normal lie on the same side of the mirror. Okay, they all lie on the same side of the mirror. This is the first rule. Okay, it's not that incident is being made this side. Okay, normal is that side. No, they are all lying on the same side of the plane mirror. Then the angle of incidence is always equal to the angle of reflection. This is second law. Okay, so when you're drawing the diagram, this angle show it equal to this angle. Okay, so the angle of incidence is always equal to the angle of reflection. This is the second rule. Okay, now put the heading laws of reflection and write down these two rules. Put the heading laws of reflections and write down these two rules. I'll give you this diagram to draw with the angles of reflection at home today. Okay? Please write this down. Write down the two rules.
Ma'am, you're frozen.
Am I frozen?
Yes, ma'am, you for a second, I think.
Okay. Have you all written? Am I done writing?
Yes, ma'am. Just
Hmm. Abraham,
Yes, ma'am, I've understood this.
uh, have you done
Ma'am,
writing?
there's one problem.
Okay, what?
Ma'am, I've done writing that explanation. Ma'am, there's one problem with this, ma'am. They've not written the normal line normally is dashed.
Means? I didn't get that, Abraham. Amma, you were saying something?
No, ma'am, I'm just saying, ma'am, that ma'am, it had to have a normal line. Normal line had to be dashed.
Normal line had to be dash.
Like, ma'am, in when I was drawing it, when I learned to draw it, ma'am, all the normal lines would be dashed, not in black.
Yes, mostly the normal lines are depicted in like in the form of dotted lines, in the form of dashed lines. True. Okay. So 5 minute break for y'all. Okay. And then we will start with maths. Okay, let's begin. Hello, Joshua. Good morning.
Hi, ma'am. Good morning, ma'am.
Good morning.
Ma'am, I have a question, ma'am.
Yes,
About this fact, ma'am. If anybody's doing the test, ma'am, I think I found a tip or a trick. Should I share it?
yes, Abraham, you can share it.
Ma'am,
Hmm.
when you're calculating direct proportion, ma'am,
Yes.
the formula has to be in such a way that x, let's say we have the question, ma'am.
Hmm. Joshua and Emma, I haven't received your maths test papers yet.
Yes, ma'am. Sorry, I was out all day yesterday, so not all day, but I was like full afternoon and evening, so I was not able. But I'll send it to you today after. I just have to finish it.
Okay. And Joshua,
Ma'am, we were traveling, so I couldn't send it.
today can you send it? Can you send it today?
Yes, ma'am, I can send it today.
Okay, do it today. Joshua, you joined in 7th chapter. So you can do it today and send me. And Joshua and Emma both. Okay? Send it to me by today.
Okay, ma'am.
Yes. Yes, Abraham.
And suppose we have the third question in index, question 7.3. If 50 plus people can construct a wall in 15 days, now how many days will 75 people construct a wall? So, ma'am, we do the diagram how you wrote in people and wall. 50, 15. And 75 and x. Ma'am. Then what we calculate, ma'am? Ma'am, what I understood is, ma'am, we need to make the equation in such a way that 50 is being multiplied by 15 and 75 is being multiplied by x.
Okay. 50 is multiplied by 15 and 75 is multiplied by x. So
Yes.
it can become
50 into 50, it's 750. So 750 is equal to 750 is equal to 75x. 750 divided by x is equal to, so x is equal to 10.
Yes, Abraham, that is correct.
And ma'am,
5.
Answer is 10 in the book, right, ma'am?
Yes, Abraham, it is 10. 10 is the answer.
Ma'am, so that's how I found out for all the questions here.
Okay. This is good, Abraham.
And then, ma'am, but ma'am, in direct, ma'am, it reverses.
Okay. This is for inverse, right? Inverse proportion.
Yes, ma'am. This is for inverse, ma'am. Ma'am, for direct, you have to put it like, let's take the first question of index question 7.3. A person purchases 3 kg in rupees 360. So 3 and no, you first like 360 and then you add under that 1810 and 3. So below 3 you'll write x, but in direct what I find out is maybe you have to arrange it in a way that you don't want 360 multiplying by 3.
Okay.
So it would be
What's the other term, Abraham? 360. Then
is to 810 is equal to 3 is to x. So that you have x multiplying by 360 and 810 multiplied by 3.
okay, 360
360x
x is equals to
is equal to 810.
810 and 3.
3.
So you have 360 multiplied by 3. No, it would be
2430, ma'am. Upon 360.
okay. Listen, Abraham, look on the board. You have like you're saying that 3 should be multiplied by 8110 and x would be multiplied by 360,
Yes, ma'am.
right? So here would be 360 should be multiplied by x.
No, ma'am. Ma'am, the way I did it, ma'am, is that I wrote 360 is to 810
Okay,
is equal to 3 is to x. That way we have 810 equaling to multiplying x and 360 multiplying x. So you get
okay.
2430
Hmm.
divided by 360, cancel the zeros.
Mm-hmm. Okay. $6.75.
Can you just repeat?
6.75 are we getting? You cannot hear me, Joshua?
I'm even getting 6.75, ma'am, which as per the book is the correct answer.
6.75 is the correct answer, Abraham. That is right. 6.75 kg is the correct answer. Joshua, can you hear me now?
Yes, ma'am, but it's very faint, ma'am.
Ma'am, does this method work, ma'am, or no?
Just a moment, ma'am.
This method is working, Abraham. Okay.
Can
What you can do is you can try a couple more questions, okay, and confirm it, okay. Otherwise, it is a good method. I think it works.
Okay, ma'am. Ma'am, I've already tried a couple more questions. All my questions in the test I filled up with this method.
Okay. It is good. It is a good trick, Abraham. Okay. It is a good trick. Emma, did you understand this trick? In inverse proportion, we arrange
ma'am.
it in such a way that 50 is multiplied with 15 and 75 is multiplied with x. Okay. Then the dp, direct proportion, you will have it multiplied in the opposite way, 3 with 810 and x with 360 to find out, to arrange it like that and then find out the value of x. Okay, good, Abraham. This is a good trick. This is a good trick. Okay. Now, Yashwa, did you understand the trick? Hello?
no,
No?
I couldn't hear part of the thing you were saying since I had to log off, ma'am.
Okay. See, Joshua, in inverse proportion, we know inverse proportion when one thing increases, the other decreases, or when one thing decreases, the other increases. That time, you write like 50 people could do the work in 15 days. So 75 people can do the work in X days. Okay. So write it like that, and then you have to arrange this equation in such a way that this 50 is multiplied with 15 and 75 multiplied with X. Okay. How? 15, 15, you can make the extremes. 50 and 15, you can make the extremes, that is the outer terms, and 75 and x, you can make the middle, means the center terms, like this. Then you can multiply 50, 15, 75 and x, and then you can find out the answer, which is 10. Okay. What Abraham did in direct proportion is that same thing, you write it down first. 3 kg honey is coming for 360 rupees. X kg will, sorry, how many kgs will come in 810 rupees? Okay, so X we have to find out. Here you have to arrange it in such a way that 3 multiplies with 810 and X multiplies with 360. Okay, so 360 and X we've taken the out on the outside, the outer terms. Okay, that is extremes, and 3 and 810 we have taken in the middle as the mean terms. So we know that when we are finding solving a proportion equation, we multiply the outer terms together, we multiply the middle terms together, and then we do it. Okay, now did you understand, Joshua?
Yes, ma'am.
Okay. Okay, so where were we on the simple interest and compound interest portion?
Ma'am, we just finished calculating rate.
Okay, did we do time also? Calculating time?
No, ma'am.
No, I think we did.
Ma'am, actually, no, ma'am, I'm not sure we did calculating of time.
Let me check if we have done calculating the time. Okay, maybe we haven't done time yet. We just did rate. Now time. Today we will see how to calculate time period. Now, look at this question. You have rate 10%. You have rate 10%. Principal 800. Amount 926.10. We have to find out the M where your compounding is done half yearly. You have to find out N where your compounding is done half yearly. Okay. First thing, we use the amount formula. Okay. We use the amount formula. Write it down. A is equals to P 1 plus R by 2 upon 100 raised to the power n. But what happens in time is that even if we are doing half yearly also, quarterly also, we don't do it by 2. Okay. We don't do it by 2 here in the formula. Okay. We don't do it by 2 here in the formula. We'll just do it at the end. So just don't divide rate and put R by 100 and put N as it is. Put N as it is. Okay. Now, what we will do is that we will put the values. See, amount is 926.10. Okay. 92610 926.10. I want to remove this point, so I put 100 beneath. Okay. Now this 0 and this 0 cancels, so it becomes what? 9261 upon 10. Okay. Is equals to principal 800. 1 plus rate is 10 upon 100 raised to the power n. Okay. Now 9261 upon 10. Okay, this 10 and this 800 you can cross multiply. Okay. So it becomes how much? 9261 upon 8000. Why? Because I multiplied this bottom 10 with the top 800. Okay. I'll take this 800 this side and then multiply the bottom 10 with 800. Okay, when I'm taking it to this side, so it becomes 8000 is equals to 1 plus 10 upon 100
Ma'am,
raised to the power m. Yes, Abraham.
would you put 2n?
Can you put 2n? No, no. We just have to put n. Okay, the r and n, we'll use the annually formula, the annual formula. Okay, we use the annual formula in all three, quarterly, half yearly, and annually. We just use the annual formula, r as it is and n as it is. Okay. Okay. Now check. You have to check that 9261 is the square root or the cube root. Okay. 9261. 9261 is the square root or cube root. Okay. We will do that and we will solve the inside bracket as well. Okay. Usually you will just understand like first I'm solving this portion. 100 is the LCM. Okay. It will become 110 plus 10. Oh, sorry, 100 plus 10.
Ma'am, isn't it 926.10?
Yes, Abraham, it was 926.10. I removed the point and put 100 beneath it. When I put 100 beneath it, it became 92610 by 100. So I cancelled 10 of 9261 and 10 of 100. So it became 9261 divided by 10. Okay. 9261 divided by 10 it became because I removed the decimal. Now here you can just write 9261 upon 8000. 110 upon 100 you can cancel.
Ma'am, I think it's equal to 21 upon 20.
Yes, Abraham. Oh, 1 second. 1 second. I made a mistake. I made a mistake. Okay, so it actually is. So sorry, I got it confused. It actually is r by 2.
And ma'am, it's n by 2 also, ma'am. N into 2.
N into 2.
Ma'am, because of compound interest.
Yes. 2n. Okay. So sorry, I got this a little confused. Okay, this becomes 5 because rate is 10. When you divide it by 2, your rate becomes 5%. Okay. Change it to 5. Here also, it becomes 100.
Ma'am, is the answer 1.5 years?
1.5 years. 1.5 years. Nine two six one is the cube of 21 8020 cube. 21 upon 20. Okay. So you can write it as 21 upon 20 cube, and this 21 upon 20, the n that was there also becomes cube. Both the cubes you can, no, the n also becomes cube.
Ma'am, this is
Yeah.
similar to calculating rate.
This is similar to calculating rate. Yes, this is similar. Okay. Now
Ma'am,
2n, because it is 2n, n for half yearly is 1.5 years.
ma'am, in this, ma'am, what we do, ma'am, is we don't ma'am, we don't when we are calculating the rate, ma'am. In this one, we instead of canceling 3, we cancel 21 upon 20 and 21 upon 20, right, ma'am?
Yes, Abraham. Yes, we can cancel 21 upon 20. Okay, and then what the power on one side is will be the power on the other side. That is, what power will be there here? 21 upon 20. Um, on the left side, the same power will you'll consider for n, which is on the right side. Okay. Please write this down. Once you're written, just let me know.
Ma'am, can you give us a question like this?
Yes, I'll give you a question like this.
Done, ma'am.
Done. Okay. Okay. Try out this question. Amount is rupees 3,087. Principal is 2,800. Rate is 10%. Compounding is being done half yearly. Solve this and find out.
Ma'am,
Yes.
ma'am, in this question, ma'am, 2803,087, ma'am. Ma'am, we have to find out the square or the cube, right? They're squares or cube, right?
Squares or cube, Abraham? Correct. Squares or cubes?
Ma'am, time is 1 year, right?
Yes, Emma.
Time is 1 year.
1 year, Emma. Correct.
I'm not able to find the cube. Does it whether it's a square or a cube?
Okay, Abraham, because it might have been coming in decimal, right?
Ma'am, there's no decimal in this.
Okay. All right. So some numbers you will find where like you won't be able to do their square or cube. Okay. So what we will do is we will divide 3087 by 2800. Okay. You do that, Abraham. You do that.
3087 by
2800. You will get 1.1025. Raised to the power n. In some very rare cases, you will not be able to find the square or cube of amount and principal. That time you divide the a by p. Okay, you will get one number. Okay, you will get one number. What you have to do with this number is you remove the point. When you remove the decimal, you will get 11025. Okay, do its prime factorization. Okay, do its prime factorization and you will get square. Okay, square root. You'll get square root of 11025. Okay, you will get a square root of 11025. Its square root will become 105. Okay, but we have to put decimal. Okay, we have to put decimal. So what we do is we will put decimal after 1.
ma'am, but we can do it upon 100, no ma'am.
We can do upon 100. We can do upon 100, okay? But this is actually the square, Abraham, okay? To show it in that format, we are just...
And then 102 to square is equal to 5 upon 1 plus 5 upon 100 n. So I understand now how it's 1, ma'am. Ma'am,
Yes, Abraham.
can you just give me a sum for me to solve?
Abraham, your homework is 9.5 to solve. Full thing.
Now,
Okay.
can you repeat?
Your homework is 9.5, solving 9.5. Okay. 9.5 has 5 questions. One I give you right now, this one. Okay, remaining 4 questions you do. 9.5. Okay. So what happens now is that it becomes n becomes 2, n
Ma'am, I understand. Thank you.
understood. 9 n becomes 2 and half yearly becomes 2 divided by 2 equal to 1, which is your answer. Okay.
Ma'am,
Yes, Abraham.
I understood, ma'am. Thank you. Ma'am, from the next chapter, ma'am, you want us to keep a graph book?
A graph book. What is the next chapter?
Ma'am, the next chapter is talking about geometry.
Okay, I'll check out the chapter, and if you need to keep a graph book, I'll put a message in the group. Okay.
Yes, ma'am.
Okay. Homework is exercise 9.5. Please do 9.5.
Ma'am, can you send it on the group, ma'am?
Yes, yes, Joshua, I'll send it on the group. Okay, have you copied this question, Joshua?
Yes, ma'am.
Okay. Okay, then that's all for today, and I'll see you tomorrow. Bye. Have a good day.